Hi guys, and welcome everyone to this screencast where I'm going to talk about doing Erlang stuff in the web arena. So to illustrate it all, I've created a small JSON-based application named Sticky Notes, which covers the 4 usual actions you can do when working with the database: create, read, update, or delete records. So basically it gives you the possibility to add a new sticker on the screen, put some text in it, change its properties. For instance, I can change its color by clicking that button here, or its position by moving the node around the screen. I'm going to add a new one and stress my application by copying these Unicode examples here. I'm reloading the page, and as you can see, the round trip to the server didn't break any of my text format. And finally, we can delete a node by dragging it on the trash bin, like this. Here I'm going to assume that both Erlang and MushyWeb are already installed on your machine. So in order to create our empty application, we are going to use this script under the MushyWeb scripts directory, which is accepting 2 arguments. The first one is the name of the application, in our case Sticky Notes, and the second one the location. So we want to create an empty skeleton in our home directory. So here, as you can see, Sticky Notes has been successfully created. And basically all my HTML pages, style sheet and JavaScript are going to be located under the prive directory, and I'll find all my Erlang modules here. Since we want to play with the database, we need to do 2 more things. The first one is to tell our application where to find the database. So for the sake of simplicity, I'm making a new directory named db, and I'm going to edit the starting script in order to add a new parameter to the Erl command. So I'm telling Nisia where to locate the files in db. Okay. So the second thing to do here is to ensure that Nisia is going to start and stop along with the application. For that we need to modify this module, Sticky Notes, and here the same way we are ensuring that crypto is starting and stopping together with the application, we are going to do the same with Nisia. So here for the start, and here for the stop. Okay, I'm saving. We can compile our code now. All seems okay. And now we are ready to start the application. And as you can see, Nisia has been properly started. We are going to check it all by browsing our localhost address on port 8000. And MushyWeb is running fine. Cool. Here is the big picture. I'm briefly going to explain what happens when we click on the Add button. First, we are going to build a JSON with an empty node's properties here, doc, and the action related. We want to create a new node. Next, using the stringify method from Douglas Crawford, we are preparing the data. And here, using jQuery, we are actually sending the data to the server. So don't forget to mention the data type. We are playing with JSON, and here, no matter the action, I'm always using the same path, nodes. At the server side now, after passing the request, I'm using Mushy.json to convert the data into a native Erlang structure, a tuple of property lists. And before sending back any response to the client, I'll use Mushy.json again to encode back the data. The callback here will be responsible for the rendering using pure. Before any coding, I have to tell you that I'm cheating a little bit here. We are going to start with a pre-coded version of sticky notes, since I don't want to enter all the client-side implementation details. I just would like to focus on the create action. It's going to be easier for me to explain and easier for you to understand the overall process. Having said that, all my client stuff are located under the private directory, as I said before, and here is my unique HTML page. So as you can see, I'm using the Douglas Corford library, jQuery, and here I'm using Pure, which is fantastic when it comes to do templating at the client side. Trust me. The HTML is quite simple, and here is my unique template for a node. So as you can see, there is no mixing between code and HTML, which is fine actually. Okay. When a request hits the server, we are reaching this module, the sticky notes underscore web module, okay, and entering this loop with two arguments. The first one is the request itself, and second one, the document root. There is a big case statement testing our request method, and we are going to code here in the post part, adding a new clause testing our nodes path. So here my code is going to be divided in three parts. In the first one, we are going to parse the request, get the JSON, convert it into an Erlang structure. In the second one, we are actually process the data, and what I would like to do is to dynamically map the action name with the function name of the nodes module. It's the module where we are going to put our create code. And finally, we are going to send back the data to the client. So let's start by parsing the request. And here I'm using the request module and the parse post function. The result will be a property list, a list of key value pairs. Here I'm getting the JSON part using the prop list module, and I'm getting the value of the JSON key from that list, the data list. So if you remember the slide just before, here we have actually sent to the server this key value pair, and I'm using the same here. Okay, so we are ready to convert that data into an Erlang structure, and I'm using Mochi.json to the decode function. Okay, so at this point we are able to play with that structure, and so as I said, what I want to do is just to dynamically map the action name with the function name. So first, from that structure, I'm getting the value of the action key, and here I'm using the struct module, which is a module that I've created to ease the manipulation of this kind of structure from Mochi.json 2, which is a tree actually. Since I want to use that as a function name, we need first to convert that binary into an atom. So the slide again, here I'm getting the value of action, which is a binary, create, and we need to convert it. So first I'm going to convert that binary into a list, which is a string actually, and I'm going to use the result of that function as the argument of the list to atom Erlang function. Okay, we can use action as a function name now. So my result will be the return value of the nodes action function with one parameter, the structure. Okay, nodes is the module that we are going to code in the create action. And now we are ready to encode back our result in order to send a response to the client. So I'm using here Mochi JSON2 again, but this time with the encode function, and I'm using result as the argument. OK, and finally we can use the request module, the OK function, which is accepting one argument, a 3 elements tuple. So the first in the first one I'm telling that we are sending back JSON data. The second argument will be for the cookies, but we don't have any, so it's going to be an empty list. And the last one is our data. So that's it for this module. Now we are ready to code or create action in the nodes module here. Let's open our nodes module now. As you can see, all the actions, all the functions have already been coded for you. They are actually quite small and easy to understand. And here we are going to add our new function named create with one argument, which is our structure. And the first thing we are going to do is to get from that structure the node information. That's what I'm doing here. So we are getting the value of the doc key. And here again, if we come back to our previous slide, we are getting this piece of information, which is a structure containing all the properties of a node: text, position, and the color. Since we want to create a new record on the database, we'll need a new ID. That's what I'm doing here. I'm actually asking for a new ID for a node, and I'm using the StickyDB module, which is a module that I've created for this application in order to group all the functions related to Mnesia. We are now ready to write to the database, and using the StickyDB module again, but this time with the write function, which is accepting one argument, or node record, with two fields. The first one is the ID and the document. Okay, so before returning any value, our client side will need that new piece of information, that new ID. So we need actually to convert to add this new information in our initial structure. That's what I'm doing here, but this time using the set value of the struct module, which is accepting 3 arguments. The first one is the key name, the value, and our structure. And since our client is waiting for an array of 0 or more elements, I'll return a list with my new structure. Okay, so that's it for the create action. And before compiling our code, I would like to briefly open these two files, the records one and the StickyDB module. Okay, let's start by opening this include, which contains the record definition, the first one for the counter, and here is our node structure, a 2-element tuple. Okay, here is StickyDB, and we were using the new ID function here, so I'm using the dirty update counter to actually increment the ID. And here is the write function, and here I'm creating an anonymous function with one operation, the write operation, and I'm using the transaction system from Nisia. So I invite you to read the documentation, which is well done. A quick word about the reset function here, which is actually it's a hard reset, and it's creating the tables based on the record information here. So here we are. It's time to compile our code and give a spin to our application. Here we need to call the StickyDB reset function that we have seen previously to actually create the database. We need to do it only once. Okay. I'm going to open Firebug in order for you to see what happens behind the scene, adding a few nodes here. All seems okay. So I intentionally developed the client application in order to send as much as request as possible. There is no optimization. So each time I move, click, or lose focus a node, I'm actually asking for a service, as you can see here. Okay, that's it. I hope that you enjoyed this video, and happy coding. Bye everyone.